Okay, so next up, I mentioned that I'm not going to do the other arm here with you right now to save time. I'm just going to jump straight to the roof. But you know at this stage that the same way we moved the guardrail from one side to the other, we can do the same thing with the arm. It's exactly, we're just kind of recycling the same ideas for all the new geometry that we're creating. Now, the roof is a little bit different, ever so slightly. The roof is going to be made up of a curve that's kind of a compound curve because it sort of tails up at the ends and then it has the arc in the center. So we need to think about how we're going to generate that geometry. When I think about it, I look at the picture here, and one thing that kind of jumps out at me is that the roof is a little bit longer than any of the geometry I've created down here. That's okay. We can work with that. We just need to consider whether or not what am I trying to say? We just need to consider whether or not we can build it off of the geometry we currently have, or if we have to build it off of new geometry. I kind of want to give you a little bit of a tip about like calibration and stuff like that, just to kind of spark some creative juices about how you might start to diagram or even plan things. So let's jump into this. So I think the way that I'm going to do this is, since I generated a series of, did I do it off of a point or a curve? I did it off of 3 points. Okay, yeah, so I actually modified 3 points in order to generate this. I think what I'm going to do for this is build it off of points again. And since I'm kind of going back to the base geometry, and it's, since I'm going back to the base geometry, I think I'm going to do a separate idea, and rather than building it off of any of this, I'm just going to move it down below. So these 3 points, I'm going to borrow. Okay, so that's those 3 points right there. But I also am going to need a few other points. I'm going to need a point that's probably, I'll call it, let's do 10 feet, negative 10 feet, push it off that way. And then I'll do another point that is 10 feet that way. Are they still aligned? Yeah, they are. Cool. All right. So they do need to be sort of aligned for this. But anyway, so I'm going to go to params and make sure that I reference all those points in. This one is on the left, so I'll make this one the leftmost point. Whoops. There you go. And then this one was on the right, so I'll make this the rightmost point. All right. One thing that I think I kind of want to adjust is this point right here. I'm going to use a set of straight reference points that are all on the base plane, and I actually don't know exactly what height this is, so I'm going to move. I'm going to grab that point. Make sure you have project on when you do this, which it is on. That's good. Move it down there. Oh, whoops. I need to do it this way. Copy it, then move it down. There we go. All right, so then this one, since it's a copy, I don't have to unselect it. I can just say set 1 point instead and put it down there. It won't disrupt anything. So these are 5 new point references. They happen to all be on the XY plane. Does anybody know why I'm doing this? Because I'm going to build a control curve that's going to measure the distance from the ground and then reconstruct a curve for me. So it's going to look like this. These were originally 50 feet apart. If you do your distance command and you go from point to point, that's 50 feet. Plus 10 feet on either side, that's a 70-foot distance. I can do this in the top view. I can just draw a line that goes 70 feet and put it right here. Okay, that is my ground plane. So I can very easily just drop a point on there. I can say, let's make another one 10 feet, another one 25 feet, another one 25 feet, and another one 10 feet. Why am I doing this? It's so that I can pull them up off the ground a certain distance. Let's say, actually I don't know what height I need right now, but let's go with 20 feet for now. Okay, and I'm going to build a curve with these. I'm going to move the middle one up, say 8 feet, and I'm going to move these two end pieces up 3 feet. That's going to be my profile curve. And the way it's going to look when I'm done with it is, whoops, control point. There we go. That. So that's going to be the curve that generates the roof for my bridge. But I don't really need that. All I need is the points here, the referential distances from the ground plane. So I need to reference that ground plane curve in, and then I need to reference all of these in as well. So this is going to be sort of a combination of a few things. These points right here that I referenced in my model, in their correct orientation, these are going to be the model roof base points. And I'm going to need to do another series of 5 points in the same order. Deselect those. So I'm going to say set 1 point here, set 1 point there, set 1 point here, number 4, and number 5. Okay. These ones are my analytical roof point elevations. So this relationship is going to be based off of its distance from that curve. I'll kind of separate these a little bit. And the curve is right here. So I'm going to say set one curve. I'm going to call this one analytical ground. So that analytical ground, I can sort of break that up into points. What you need to know is that it's point by parameter. It's not going to be a division of points because the spacing is irregular. So I'm going to go to curve analysis, and I'm going to do where's my parameter ones? Evaluate a curve, certain factor of its length, no. Measure the length of the curve to and from a parameter, perp frame, specified curve parameter. Evaluate a curve at the specified parameter. That's what I want. So this is going to take the curve, and then it's going to take a list of parameters. What do you think those parameters are going to be? They're going to be the foot distances as a percentage of the overall length. All right, so this one's going to be a little bit weird, and you're probably going to have to revisit this one kind of cleverly. But we need to tell it how many feet it's going to measure to, and this is going to have to be on multi-line data. So our first distance was 0 feet from the end of the line. Oops, sorry. The next one was 10 feet. The next one was, let's see, it was plus 25, so that's 35 feet. And then 60 feet, and then 70. So that's 0. That's all of the foot distances from point to point across the overall line. But those aren't parameters because we need a percentage of 70. So let's do. I think we can just do it with division. So we'll go up to Math, Operators, and Division. And we're going to divide these, let's see, by 70? Or is it 70 divided by that? I think it's by 70. Plug that in here, plug that in there. Yeah, that's right. All right, so what we get is a list that looks like this. It's 0, 0.14, 0.5, right? That's halfway, and then 0.85 and 1.0. Okay, so that's the parameter, right? The percentage distance across that line or across our bridge that each of those points lives. So that list will be our parameter, that's this, and then our analytical ground is going to be the curve that we're breaking. Oh, does that need to be reparametrized? Yeah, it looks like it needs to be reparametrized. Okay, so just like the switching from magnitude values to percentage values, you could reparametrize that. So it looks like if I was absolutely calibrated and I didn't want to use that, I could actually just plug this value in and it would do the same thing. So we didn't need to do the division at all. All right. Well, that's pleasantly surprising. Anyway, so now you know how to do it both ways if you need to. So here's the key, right? We have 5 points here. We have 5 points here. I need to measure the distance of each of those points to each of their respective analytical points on the ground plane. So I can, the trouble here is that these are all separate lists, right? Literally, they're all in separate houses, and so that means that they each create a separate list. But this one is all one list. So I need to take those 5 points and I need to combine them into one list. So that would be under set, tree, and merge. Okay, so merge is going to take this list, that list, and it's going to keep adding an extra point until I'm done. And what I'm going to get is a list of all 5 points in one list, like that. Okay, now we have points up here, we have points down there. I just need to measure the distance between the two. So I can go to curve analysis. I think it's under curve analysis. Might be under vector. Distance. Yeah, it's under vector and point, and it's distance. So we're going to measure the distance from A to list B, and what we get is that, which makes sense. We have 23 feet, 20 feet, 28, 20, and 23, right? Going up like this, the curve that we designed. So that is going to be our magnitude for how we move the points on the actual model. So these points are going to be moved by that magnitude. So I'm going to do a transform. I'm going to use Euclidean. I'm going to move. Let's get back into perspective here. And I'm going to also get under vector, vector, amplitude. So this is a vertical application in all cases, because this is a physical-based idea. So we'll go to vector, vector, and we'll use unit z. I think it defaults to z, but yeah, maybe it doesn't at all. Anyway, so the distances are going to be our magnitudes. Whoops, that needs to be down here. Wait, hang on. What am I doing? Oh, never mind. I don't need amplitude. Sorry. We're using unit z. So that is the direction, and we created the magnitudes. Those will plug into here, and we're going to need to actually do the same merge on these points as well. So I'll go back into set, list, tree, merge, and I'm going to pull all 5 of these in. That makes one list for all 5 moves. That'd be those here. So, with that, I just want to point out that if we go to curve and spline and we create an interpolate curve, we have a list of vertices that we can plug in, and the curve degree is something different that I'll explain in a bit, but we plug that in right here, right? That creates our profile curve. It's a little too high, right? We need to calibrate this a little bit. So since that's a little bit too high, I can go back into my top view. Let's put this into a view like this so that you can actually see what's going on. I can go back into my top view, grab these points, and start yanking them down to get it to calibrate. That's still a little bit off because the curve is a little bit too tight. So I can take these 2 points and I can pull them up. And then I can pull this point down maybe a half a foot. And you just keep working on calibrating it until you've got it in the position that you want. That's probably close enough for our purposes. Okay, so that's kind of why I wanted to build this for you, is because I want you to understand that referential geometry doesn't just have to be on the actual model itself. You can do all of your analytics on the side and calibrate everything in diagrammatic fashion. And that's what this is right here. It's diagrammatically applying the idea to your model. So let's recap real quick. All I did here was this little section right here. I have my, I created an analytical ground line, that's that. I created 5 analytical roof points. Those were the ones that kind of float above. I created 5, I referenced 5 model base points. Those are the ones that were on the ground in our actual model, in their proper orientation. And I just measured the distances from the analytical ground to the analytical points. And then I moved them to create an interpolate curve on the actual model. What questions do you have? No questions? You guys all kind of understand what that was? Even if you don't understand all the tools, you understand the idea of what happened? No? I'm not convinced, guys.
I don't know why you just didn't, like, it seemed very complicated to do something that, like, I feel like it would have just been easier just in Rhino to just put those points there. That's where it seems really complicated.
Sometimes, yeah. So here's kind of what I'm simulating. You're right. Theoretically, the points that I put in the ground plane here, these ones, I could have just done that in place. You're absolutely right. The reason I did it this way is because since it's on the side, I have a totally isolated area to look at what it actually is. Like, I'm looking at this thing basically in elevation as a schematic drawing. All I see is the ground plane and the roof plane and what that curvature is. And yeah, you know, it might not be the most useful thing to you apparently right now. But when you get to a point where you're starting to analyze the curves in louvers or something like that, you need to have a profile curve that's separate from your model so that you can really see a calibration of one singular system versus the deviations throughout the entire system. Does that make any sense? Do you guys know what the signal box building is? So I did a Grasshopper tutorial on this facade once, and I used this method on this facade. So what I could do is look at one louver in a diagrammatic fashion, and then have that apply as a series of variables throughout the overall facade. Does that make any sense? Like I could take the curve, because all these things are doing, they're all just louvers that are bending up in the middle. So it's a very similar curve to the one we have. And so I can diagrammatically look at what that bend's magnitude is going to be as a curve, and then modify that, you know, separate from the building referentially. Does that make any sense? Make a little bit more sense in terms of its applicability, or no? Well,
so it's like a separate system?
Yeah,
Okay,
yeah. It abstracts it to be something that's purely analytical. Any other questions? Okay, let's finish this thing off. It shouldn't take very long.